Hey everyone, today we're going to take a look at lesson 6, rational exponents. Alright, so we have our concept b to the 1 over n, and this is saying b, for any real number b and any positive integer n, we have b to the 1 nth is the same thing as the nth root of b, except when b is less than 0. And n is even. When b is less than 0 and n is even, the complex root might exist. So what we have here, for example, 27 to the 1/3 power is the same thing as saying the cubic root of 27, which is 3. And then if we say negative 16 to the 1/2, that is the square root of negative 16, which would be 4i. And as always, pause the video as needed for you to go ahead and take your notes. So for our first example, we're going to have write a to the 1/7 in radical form. So by using the definition of b to the 1/nth, we'd get a to the 1/7 is equal to the 7th root of a. And that is all we need to do. The same would apply if we're going to the exponential form. Remember, if we do not see anything here in the n value where the index would be, it is a 2. So w to the 1/2 is the same thing as the square root of w. All right, go ahead, pause the video and try this one out. All right, so going ahead and moving forward, we know the index would be 3, so I'm going to get the cubic root of a, which is c. Pause the video to try this one. So we have our index is 5, so that means my denominator would be 5. So my answer is x to the 1/5. The whole point of writing in exponential form is that we get rid of this radical, which is why we can't pick b or d. All right, so we're going to go ahead and evaluate. So we have 49 to the negative 1/2. So we have our first method, which we can go ahead and start simplifying and using the properties of exponents and moving this to the denominator. So we get 1 over the square root of 49. Well, the square root of 49 is 7, so 1/7. That is one option we have. For method 2, we take power of a power and do 7 squared times negative 1/2, which gets us 7 to the negative 1, which is just 1 over 7. I probably prefer method 1, but that's just a preference. All right, so we're going to evaluate 32 to the 2/5. So we can use method 1, which would be using properties of exponents, and they factor out the 2 to get 2 times 1/5 is the same thing as 2/5. Using power of power, they're going to do 32 squared and then take the 5th root. So they go, well, the 32 is the same thing as 2 to the 5th, and they rewrite it this way. And so they get 4. To be honest, I probably would not use that method. So here's another option we have is rewriting it as 2 to the 5th to the 2/5. Power over power, and we get 2 squared, which is just 4. So there's a couple of ways of doing this one. There's not really like any single right way to do it. One option you do have, if you do have a calculator that lets you pick your index, you can type it in as the 5th root of 32 squared. Or you can just do 32 squared, take the 5th root of it. That is an option, but that requires you actually having a calculator that lets you do that, which both the Desmos and Inspire do let you do that method. And that will probably be the easier route to go. So go ahead and evaluate 25 to the 1/2. Pause the video. All right, so with this, you should get b 1/5. Take the square root of 25 to the negative 1. which would get me the square root of 1 over 1 over 25. There it is. That's what's happening. And we can use properties of the quotient property, which would let me break this up into two separate ones, which would let me just get 1 over 5. That's one way of doing it. Or again, if you have the option of having a calculator that lets you, you could go ahead and do that part in the calculator. 16 to the 3/4. So one thing I always do, I always remember that anything to the 1/2 gets me a square root with an exponent of 1 on the inside. So this would be the 4th root of 16 cubed. And with that, we get 8. All right, so rational exponents. And here's one of the things that I just mentioned that I did in the last problem. For any real numbers, non-zero b and any integers x and y, with y being greater than 1, b to the x over y is the same thing as taking the y root of b to the x, except for when b is less than 0 and y is even. If that's the case, we get a complex root, and we'll deal with that as needed. But this is very helpful, very, very helpful. So one thing that we would do, so b to the x over y, we will also say maybe exponent over index. You might see the word power over index, power over root, something to that extent that they might try to make you help you remember to know which placement goes where. So here we have weightlifting has the formula m equals 512 minus 146,230, b to the negative 8/5. This can be used to find the estimate of the maximum total mass a weightlifter of mass b kilograms can lift using the snatch and the clean and jerk. So using this formula, how much could a weightlifter weighing 168 kilograms lift? So in this case, we would just plug in 168, which gets us about 472. So go ahead and try this one. All right, so with this, you were just supposed to plug in 80, and you would have gotten C 380. So we can also do properties with multiplying. So we're going to do the same process when we multiply variables. We would add the exponents, and to add rational exponents, they have to have the same denominator. So we get 5/7 here. Here we have simplify x to the negative 2/3. So we don't like having negative exponents. So we can go ahead and write this as 1 over x to the 2/3. The other thing is we do not like having fractions in our exponents in the denominator. So we're okay with exponents as fractions, but we don't like having exponents as fractions in the denominator. It's a weird rule, I know. So we go ahead and multiply by what would make this a whole number, which would be x to the 1/3, because 1/3 plus 2/3 is 3/3. So we get x to the 1/3 over x. And that would be our solution. All right, go ahead and try this one. All right, with this, you should get x to the 3/5, because 1/5 plus 2/5 is 3/5. All right, go ahead and try this one. All right, with this, we're going to get C. So what we're going to end up doing is you have 1 over y to the 3/4. And you're going to multiply by y to the 1/4 top and bottom, which will get me C. All right, for example 5, we're going to go ahead and simplify the 6th root of 16 over the 3rd root of 2. So this is one of the times it probably would be helpful to go ahead and have these written as an exponent rather than a radical, since these are not the same type of radical. When we do this, we get 16 to the 1/6 divided by 2 to the 1/3. And we can go ahead and rewrite so that we have the same base of 2. So 16 is the same thing as 2 to the 4th. So this is very similar to when we were in chapter 7, or if we haven't in chapter 7, where you have to have the same base, which would be in this case 2. So we get 2 to the 2/3 over 2 to the 1/3, and using quotient property of exponents, we're going to head and subtract the exponents. So we have 2/3 minus 1/3, which is just a 1/3. So we have either 2 to the 1/3, or you can say the cubic root of 2. All right, so we're going to take the 6th root of 4x to the 4th. So we're going to rewrite this as a rational exponent, and we can go ahead and distribute the exponent. And we can simplify this to 3, the cubic root of 2x squared, because they rewrote 4 as 2 instead of 4. So again, it's all preference. So the cubic root of 2x squared. Next, we're going to have to rationalize the denominator by multiplying by the conjugate here so that we can simplify. Because again, we don't like having fractional exponents in the denominator. Numerator is completely okay. So we multiply by the conjugate of the denominator, which is y to the 1/2 plus 1. And when we do that, again, it's taking that concept of a difference of 2 squares so that we eliminate that middle term that would have the exponent of a fraction. And we're going to get y plus 2y to the 1/2 plus 1 all over y minus 1. All right, go ahead and try this one out. All right, you should get b, which is 1. Yeah, that's all I can say. All right, go ahead and try this one. All right, you should get a, the cubic root of 4x. And then lastly, go ahead and try this one out. All right, and we should get a. And of course, we have our checklist to make sure that we have rationalized or simplified as much as possible, which means we have no negative exponents. There's no exponents that are not positive integers in the denominator. And the keyword here is not positive integers in the denominator. That is the only thing I am allowed to have in the denominator. We do not have a complex fraction, and the index of any remaining radical is the least number possible. So if it's one of those, I can write it as a square root instead of a 4th root, that is what I want. We want the lower index. And that is the end of lesson 6-6, and I will see you next time.